Hi, this is Moein from AI Lab at Mayo Clinic. Thanks for stopping by, and I'm making this tutorial video series about nnU-Net. If you didn't see episode 1, check that out there. That was about nnU-Net installation, and this episode is about quick start on training a segmentation task by nnU-Net. To have a smooth nnU-Net training, we need to do 3 main steps. The first one is renaming data in the nnU-Net format, and then preparing a JSON creator file compatible with nnU-Net, and finally running the training command. However, you don't have to do this, but I would recommend, based on my experience, to rename data in the nnU-Net format before we create our JSON file. So in this way, we'll have integrity with nnU-Net format, and we'll have a smoother training and less headache. So to do this, I would recommend, for training images, training labels, and test images, run this Python code for renaming the data in the format of a prefix and a serial. And what you just need to do is changing the folder path and changing the prefix, which is usually a 3 letters abbreviation. Next step is preparing a JSON creator file compatible with nnU-Net, and that is playing an important role in having a healthy training. If we go to main nnU-Net GitHub page and click on the third folder, nnU-Net, you'll go into another page, and then you need to click on Dataset conversion. And if you click on that, you'll see multiple files that are created for preparing a JSON file based on the task and modalities for each data set that people have trained before. You can pick one of those files and just easily modify that to have a JSON creator file. So I'm going to show you here how to do that. So here we are in the nnU-Net page. We click on nnU-Net and then dataset conversion. So in this tutorial, because I'm going to train on our in-house multivariate dataset, and I'll edit this file for my task. To modify the JSON creator files available on nnU-Net GitHub page, based on your task and your dataset, you need to modify the folder path to your raw data, and then modify the task ID, the task name, and the prefix, and also modifying the folder path to raw data for training label and training images and test images. Then if we scroll down on the files, you see some integers. We definitely need to be careful about these range based on the number of scans that we have. And also we need to modify the JSON dictionary and then the modality, which is very important. Like for CT, we have 0. For if we have more modalities in MRI, then we have to have 0, 1, 2, 3. And then it is important to define the labels accordingly to your data set. If you have 1, 2, 3, 4, or whatever, here we see 13, but I have to modify it for my task because my data set has 33 organs, and I need to modify this in my file. These are the folders that we've created for installation. Now, after running the JSON creator file, we want our task to be created in the nnU-Net raw data folder. Let's check. We go into nnU-Net frame folder and then Dataset, and then looking for nnU-Net raw, and then into nnU-Net raw data. Then let's see what's in the folder. Here we go. The task 17 multi-organ has been created. If we go into that folder, we'll see, let's clear the page, we'll see the dataset.json has been created, 3 folders named image.tr, image.ts, and label.tr are created. Here I'm using few scans just to save time and show you how the process is. Now let's dig into the dataset.json file that is being created and see how does it look like. So you see that we have 34 labels. You see each image and label are appropriately put together for training and everything looks good. Now we are ready to decathlon the data set. So we need to go to data conversion instruction and copy the command for nnU-Net convert decathlon. Here it is. I copy this command and I just need to change my task name. However, it depends in which folder you are. First, don't forget to activate your virtual environment that you have the nnU-Net installed there. Then we go to the nnU-Net raw data folder. So we have our tasks there. So I choose the task 17, which I have just created by that JSON creator file. So we'll see that we got no error. Looks great. So the reason it was so fast because I chose only 3 scans, and that's why I used few to show you these steps faster. Next, we need to check data integrity. So to do that, we'll go to nnU-Net main page and experiment planning and processing. Then I'll copy this command. Let's clear the page. Now I paste it into terminal. Change the task ID to 17. Then press enter. It's running well. Here you see that everything went well, and now we are ready to run the training command. To do this, we need to go to nnU-Net main page and then choose if we want to train a 2D unit, a 3D full resolution, or 3D cascade. So here are the commands that you can choose for your task. Here I'm going to do a 3D full res, and I copy the command here. Then paste it into the terminal where my task is here. So if you remember, I put only 3 scans in the task 17 that I showed you, but that doesn't give you a meaningful training. I already have a task with 80 scans, so that's why I'm going to train that task, because that would be a real one and the results would be meaningful. It's up to you what fault number do you want to use if you want to do the cross-validation. So here I put 1 just for the sake of time saving, and then I choose my task, and here you can change the version of the trainer, version 2 or 1. So version 2 is for sure updated one. So then we press enter and the training will start. After some epochs, I might interrupt the training because nnU-Net wants to run the task by default for 1000 epochs. Now let's see where the results are stored and where we can find the training curve, the training log, and retrieve the results of the training. As shown here in this folder tree, we should go back another folder and again go to the nnU-Net trained models and find the result. Now I go into nnU-Net trained models and we'll see a folder named nnU-Net. Getting into that folder, you'll see another folder named 3D Full Res, and then we should pick the task that we already trained. I used task 509 because I already trained this task for 1000 epochs, and then I pick one of those folds that I have trained. For example, if we go to fold 1, you'll see the training curve. Also, best model that was saved by nnU-Net and the training log. Let's have a look at the progress.png file, which shows the training curve, and see how does it look like. Thank you for watching episode 2 of the nnU-Net tutorial series. In next video, we'll show you how to perform inference for nnU-Net.